We are taking you behind the scenes of the National Institute for Data Science and Artificial Intelligence.
With unprecedented access to the scientists pushing boundaries and shaping our future, this show will take you to the cutting edge and beyond.
And whether you're an expert yourself or just science curious, this is the show for you.
Welcome to the Turing Podcast.
Hi everyone, welcome back to the Turing Podcast. I'm your host Ed and I'm here with Aoife. Hi Aoife.
Hey Ed, how's it going?
Not too bad, how are you?
Yeah, I'm good, thank you.
And today we're joined by our guests Kate Highnam and Myles Foley, both of whom are PhD candidates at Imperial College London. They work at the intersection of machine learning and cybersecurity, and they were part of a team who last year won the CAGE Challenge, CAGE being an acronym for Cyber Autonomy Gym for Experimentation, with their reinforcement learning based solution. Kate and Myles, welcome to the podcast.
Hi.
Hi.
So before we get started and talking about the CAGE Challenge and your research, maybe you can just tell us a bit about yourselves, how you came to be doing a PhD and working at the Alan Turing Institute. Myles, do you want to go first?
Started getting into kind of like machine learning in my undergrad. So I did a project on reinforcement learning, trying to do packet routing for networks. And I found it really, really interesting. And it was around the time where reinforcement learning and deep reinforcement learning was really starting to pick up. So that would have been like, 2017, 2018, 2019?
What year are we in now? 2023.
2023.
So good 5 years.
A couple of years ago, yeah.
More than a couple of years ago now.
More than a couple of years ago. Yeah, it's terrifying, but anyway. And then I got involved in some data science and did some work around security. And I then found that I really, really wanted to work on these kind of things, and I didn't know really where to do that. So I decided that a PhD was the best option for me. And then, well, actually, the reason why I ended up getting involved with the Turing Institute is actually because of Kate, who told me about some people who were working here, who are now head of the AI for cyber defense team, project leads, and they were looking for people to do some work related to it. So yeah, with that, I'll pass off to Kate.
Yeah, so I got into machine learning back in 2017. So I was working as a data engineer at a bank in the States, and I really liked data analysis. And I knew I wanted to come do a PhD at some point, and so I managed to get onto this Center for Machine Learning team and started learning the basics, and then thought I'd take the time to get a PhD and really learn a lot more as to the fundamentals and how the algorithms actually work. That brought me to the UK and Imperial, and then I've just continued that kind of line of thought and now look at data quality for machine learning and training models, and that's what my PhD is in. And I fell in love with the Alan Turing Institute when I found this area and these people that were so active in cybersecurity and applied cybersecurity as I knew it. And after having a few conversations and coming to several events, I got in as an enrichment student and then kind of poked Myles until he followed me. But yeah, no, it's this team, I think, that really has kept us involved with the Institute and the research that's ongoing right now. It's been really fun.
It has, yeah. Getting to work on these kind of things is not often that we get to kind of collaborate with people who are really interested in this kind of work.
Can you tell us a bit about the team?
Well, Mindrake is...
Mind
Drake. Mandrake, like the plant.
Okay.
Mind instead. Fun little team name we came up with.
Mandrake, actually, this is a bit of pop culture reference, but reminds me of Harry Potter. Do you remember that?
That was where it came from.
No, it's because we sat in a room and we said...
Oh, no, yeah, you're right.
And someone started screaming.
I thought it would be us as we're coding. No, we said we needed a team name. And so I said, okay, let's all sit around and pick 4 random words that come to mind. And so someone said brain, someone said neural network, someone said dragon. And then eventually I mashed them all together and we just said... I think someone cracked a joke about... Chris and I were reminiscing earlier. Chris and Vass are the other 2 members in the leads of AICD here. And they...
Because Chris made the joke about
Drake,
one of them
the rapper.
was was it Drake the Rapper? I thought it was the plant.
And then the plant.
And then it was based off of the plant. And then it's like, it's like the frustration that you get sometimes when things don't necessarily work out how you want them to. I mean, that with Mandrake.
Which is a really cute logo of like a brain with like little leaves coming out of its head, which we've now got professionally designed, and sweaters inbound.
Yeah, and stickers too.
Yeah,
amazing.
We'll pass them out.
So for the Mandrake team, is that the same team that was tackling the cage challenge? And we spoke to you a bit last year about this, but you mentioned before we started recording that you've now participated in several times, and you've definitely won at least once, I think.
Yeah, so the initial team was the 4 of us. So it was Kate, Chris, Vass, and myself. And then we won the first challenge, which was the Network Defense Challenge. And then there was a second version of it, and we placed in the top 5.
3rd, 4th, and 5th.
Yeah.
Because we had 3 submissions, and that was
competition's hotting up then.
Yeah. There was a lot more competition, which was really fun to see that much investment, right? Grow in the community. And it was with a master's student and a guest researcher that joined the team. So it wasn't just us. And I actually had a lot of work coming up in my PhD, so I had to step away for a bit.
And then there was...
I watched from afar.
You were with us in spirit.
Yes, always.
your software development practice
I was called in to yell at
to yell at me for when I do the wrong commit.
So what are the, if you don't mind me asking, what are the setups like for the cage challenge then? Is it like you sit down for a week, hackathon style, or how do they work?
That's a great question. Let's see if I can remember. It was something like 2.5, 3 months prior to the deadline of the competition. It'd been out for, I think, a couple months already.
I think, but by the time that we got involved, it had been released for like a month or 2.
Yeah.
And who's doing the releasing? Who's this set up by?
There's a team in Australia.
Yes.
But it was sponsored by the 5 Eyes, which is
right.
Australian,
New Zealand, Canada, the US, and the UK.
Yes.
And they put out this challenge just sort of for anyone to have a go at. Yeah. Right.
Sadly, no prize money, but
right. Okay.
It was one of the few gyms that we'd seen, right, that did true autonomous
keeping the alliance safe
defense.
is surely, reward enough, I suppose.
I mean, you got to walk around saying we got first and get to be on a podcast, so you know.
It could definitely be worse.
Twice.
So it was released beforehand, and then you submit your implementation, and then they test it and verify that you got the results that you say that you got, and we did.
And so the gym setup was also quite unique, right? We hadn't quite seen anyone really gamify network security.
Because in like reinforcement learning, you tend to have these kind of like environments, or gyms as they're generally called, where you try to train and have an agent interact with the environment. And then, as Kate says, it was one of the few that we saw which was kind of a promising implementation and very realistic. So you could do it in kind of like simulation, and you could just run it on your laptop, or if you wanted to, you could then use this same setup and host it on servers on like an AWS cluster, so you could do it in real time.
And the setting itself was very realistic, right? So it was
3 subnets?
3 subnets and 13 hosts. So what that means is like servers and laptops interconnected to kind of mimic what a company or any kind of organization might have. And then what we were tasked with was designing a blue agent to defend. And then they had some kind of red agent that would start attacking the system. And so slowly you had to figure out, using set actions, how do you develop a way of defending without knowing who is attacking?
Yeah.
So just to back up and add some lay people speak to this. So what was...
I was like, what other Power Rangers are coming in?
We had
blue agent and red agent. Yeah. Well, let's come to blue and red agent in a second. But so what we're talking about here is like effectively defending against hacking attempts.
Yeah.
Yes.
So you've got a simulated computer network, and so I'll say what I think you mean, and then you can correct me. So I think your red agent is an imaginary hacker. So in this case, maybe it's a bot, or maybe it's a person. But your blue agent is your reinforcement learning program that's designed to protect the network from the hacker.
Yeah,
is that correct?
Exactly.
If we want a really simple analogy, I think last time I said a dungeon, but we'll go with maybe like a house.
A house, yeah.
in like with a yard and maybe a farm kind of attached to it. So it was like the first line of defense. You could come in through various gates that maybe, or the roads that you have access to. And so as the blue agent, you're trying to figure out, how do I protect my property?
Yeah. How do I make sure all the fences and gates are locked?
And then there's like layers to get to the actual house where maybe the money is stored, right? So they're trying to get into, find where the money is, but you have many layers of defense. And so this red agent, you don't know if they're a fully trained thief or whether they're just someone who happens to be passing by.
And will chance their luck and try to steal what you've got at home.
If they just meander through your yard. Yeah.
So in terms of what that looked like, so when you came across the challenge and there's this sort of environment that is like the network, or you can set up the network. In terms of the reg agent, is this just sort of a programmed AI bot that can behave in like a few different ways?
Yes, there's a couple of different versions of it that they implemented for this. So I think they originally trialed it with 2 main agents.
2 plus sleeper.
So there was an agent which had some prior knowledge of the network or of the layout of the farm, and it would then go straight for the objective of the prize server which hosts the keys to the kingdom,
right?
Or like the safe in the house. And then there was a second adversary which had like no knowledge of it, and this attacker would just kind of like meander through, and it would slowly develop its knowledge of the network structure and then move its way through to finally get to this operational server, which it's trying to compromise. But there was also this third agent, so it was kind of like a baseline sanity check. There was an agent which would just sit on the network and just do nothing, to make sure that you weren't just kind of like banging on all the doors and
nailing all the doors shut,
resetting everyone's machine every 5 minutes.
Right.
Yeah. Security people, I think, often get a lot of bad rap for being like, please update your password, please make sure everything is updated. I know I'm not the best for it myself.
But it makes sense what you're saying, because obviously the best way to prevent a hacking attempt would be to just turn off all the computers.
Yeah.
Then no one can hack into it. Right?
Exactly. Yeah. 100% safe.
There might be some other downsides to that.
Yeah, usability might go down a little bit, which might be a problem.
But yeah, and then the challenge itself was in any scenario that they throw you into, can your blue agent defend against any one of those three?
Right.
So you don't know which one you're going to get when it comes to like this evaluation. So can you try and make something which will defend against all of them? Was then the main challenge.
So whenever you say scenario, do you mean just in terms of like your network layout, or is there more complexities to it than that?
Think of it as like a stage in a video game, and it's like you always get checkpointed at the very beginning. So the intruder is entered, and then you just play it out, but you don't know who has come in, and then you see how well you do. And so then you want to test it again, maybe against some other random person. You'll just restart the episode at that checkpoint, is what we mean.
Yeah.
Okay, thank you.
Yeah, no problem.
So when it came to evaluating the performance, was and testing you against other teams the first time when you won, and in subsequent times, like how did that happen? And was there a sort of like hackathon day, or were you just all submitting your solutions online somehow?
I guess we didn't fully answer your question earlier.
So yeah, it was just it turned into kind of like a hackathon towards the end. I think for the last day or two.
More so in the second and third. I think the first one we were actually pretty well paced.
Oh yeah, definitely.
I mean, I think we were verifying things.
No, we were,
right? But we had already submitted.
But
code.
It wasn't like an organized thing where you met other teams and so on. Like.
No, we actually I don't
never
think we had
met
any conversations with any
of the other teams.
Yeah. I think a few people have come up to us and been like, "Oh, I competed as well," and we just didn't know at the time. But it's always been more of, what is the problem and can we design a solution, but also what is the state of the art research in this area?
Yeah, exactly.
So like I know for the second one especially, right, you guys were looking at state-based representations.
Yeah, we were trying to look at so you've got the way in which the network is represented is in a couple of different ways. So they give you this very, very large vector of like processes running on machines and the IP addresses of all of them and where they are and their host names. And it's like this very large, very complex vector. And we were like, we don't really know what to do with this, but surely there's some useful information in there somewhere. So we tried figuring out some ways to better represent that so that the agent would have a more concise understanding of it. I think as it turned out that it wasn't particularly helpful. If I remember correctly.
So you were trying to give it sort of like a helping hand to play the game.
Yeah,
Exactly.
like giving it sunglasses to help keep the sun out kind of thing. So it wouldn't be so noisy and hard to see what it really needed to look at.
Right. Yeah, I mean, I don't know much about reinforcement learning, but I wonder if is it better to have more information rather than less? So,
That is
the eternal question.
Yeah.
I mean, to some extent, yes. You want to have more information, but you want it to be useful information.
Hence data quality.
Yeah. Hence
And
data
my
quality.
PhD.
right.
Well, plug.
I mean,
Very nice.
tell us a bit about that. Like, what do you mean by data quality, and how does it apply to this context?
Yeah. So I mean, it's mostly about what is good signal, and quantifying that is really, really hard. But there are several points of bias that we can point out in our data sets. And by identifying them, then what can we do? So for instance, right, if I find that two things are correlated, if I am starting to predict that if one increases, then the other one is also going to increase, that should be a good trend, right? But what if I've only got a data set where that's the case? But in real life, if I'd taken infinite samples from the environment, I might have found that that's not necessarily the case.
Yeah.
And that's just one form of bias.
So you've done the scientific process really well, but because of the data set you started with was a poor representation of reality, you've come to a false conclusion.
Yeah, and especially in security, we are always asking ourselves, what is a good representation of our reality, right? Because if we say, I can beat these 3 attackers, well, I could think of 50 other ones that we could try to go up against. And are they good? Are they representative? Are they going to help our defenses become better? Answering that is impossible.
A very difficult question.
I would argue.
The data in this case is like their strategy and like what moves they sort of make. Is that right?
It's kind of like if you wanted to be good at sword fighting,
Yeah.
and you have one teacher, does that mean that you're going to be like the best sword fighter ever? Or would you be better at sword fighting if you practiced against multiple people?
Probably.
And if so, does it matter who those people are? Because if I just pull people off the street, you're not going to get better.
Yeah, I don't
But
think
if
Dave
I-
from down the road is going to be very good to fight against. Maybe.
But I mean, this is like the whole point of RL as well, right? What environments we train them in will help dictate how well they will do in the real life scenarios that we throw them into.
Yeah, very well. I would agree with that. And the kind of, so coming back to, I guess, the data for what it is in the, in this particular challenge, in the cage challenge, was, so it's a series of observations that you see. And the observations are like from the network. So as I said earlier, there's like this large vector of things that you can use. Or there's a simplified, like a significantly simplified version of it, which I think we ended up using with a little bit of modification to represent it slightly differently. So we had like, okay, well, it's useful perhaps to know if the last action you took to maybe reboot a machine or to get a user off of the device, if that worked or not. If there's an adversary who's got like a suspicious user on your machine, you want to know if they're still there or not. So we added in some things like that. And I think we
It's a bit of memory.
yeah, a little bit of memory. We played around with trying to use like temporal structures. So understanding of like the continuous time sequences as well.
It's like playing chess, right? So sometimes it's good to make local changes that might be winning the game or getting some pieces out of your way.
Yeah.
But in the long run, does that actually make a difference? And that's also part of what we had to deal with, right?
Yeah, exactly.
As well as to encourage them to discover new
So
strategies.
New strategies as well is a potentially like difficult thing to try and get them to learn. So one of the things we try to do is there's this notion in reinforcement learning of like curiosity and of curious agents. So you want to incentivize them, much like maybe with a young child, to go off and explore and to learn from their own experiences. So we used a little bit of that as well. So we had these kind of like curious agents which are rewarded for seeing things which they haven't seen before, so that they will adapt better to different scenarios and different challenges later on down the line.
I feel like we've gone down so many tangents.
Yeah.
It's really
Yeah.
contain ourselves. We're so excited to talk about it.
No, sure. I guess I'm just trying to remember how this has been described to me before, but there's like this sort of what you were describing there was like a non-greedy strategy. Is that right? So there's one strategy which could be like in this whatever game I'm playing as a reinforcement learning agent, I know that I've scored points this way, so I'm just going to keep doing that or stuff like that. And another way would be like what you're saying, which is be curious, do things which might seem to have a lower score, but you're exploring more of the possible space in the game you're playing.
Exactly right. Yeah. So you're trying to get that kind of like baked in, so that when you take this kind of like greedy best action, that is also synonymous with or related to this exploration to find new things.
And there's an algorithm for it.
There's a whole lot, yeah.
Are they multiple?
There are several algorithms for it, yeah.
Yeah, I think explaining the inner workings of algorithms is beyond the scope of the Turing podcast.
I think that's reasonable.
But it's interesting right, that we're trying to quantify curiosity and quantify the way in which we give rewards and encourage learning in a certain manner. And that's, I think, the part of RL that I find truly fascinating.
I was going to ask a sort of broader question then. So we might be familiar from like the news of DeepMind and others using reinforcement learning for playing games like chess and Go and beating human players of that. But those are obviously very like, although they're very complex games potentially, they are games with certain rules that don't vary. When you're like modeling something like a computer network, which could, in the real world be highly varied, infinitely varied, I guess. How do you, like, based on your own work so far and what you've seen, like how well do you see reinforcement learning or other types of AI being useful for these kinds of like real world tasks, like defending a computer network?
That's a difficult question. How well do I see it working for stuff like that? I think it depends on a couple of things. I think the main one, which I was talking to some people about recently, is actually data quality and trying to get these large quantities of data that we can actually like try and train these models on, whether that looks like a reinforcement learning agent or a large language model, something similar to like the chat GPT of network defense, is something that we probably would like to see maybe at some point down the line.
What do you mean by that? How?
So what do I mean by that?
Were you typing into the chatbot, please defend against hackers?
Yeah, can you stop them breaking in? That would be great. Yeah. I would love to see that.
But people have taken ChatGPT and like given it code samples and said, is this vulnerable?
Yeah.
Right.
There's a couple of different versions of it which are for penetration testing. So this is trying to find, similar to like what the red agents in the Cage Challenge are doing, is trying to find the vulnerabilities within the network.
Right.
So they've hooked it up.
Throwing things at it until it breaks.
Yeah.
I mean, presumably in the large language, or in the ChatGPT case, that's just sort of searching its database of like text from the internet, which includes articles about, common hacking attempts.
Potentially, yes. But then you move into the more specific, like security-based thing, which is, can I make use of the network logs or the traffic that's going around of the packets on our network? Who's on the network? What are their behaviors like?
But is it not picking that up from like someone's blog that it's got in its database?
It's
like a network security blog?
But those blogs, they vary in technicality, right? And it's also tailored as well to the system in which the data was collected in the first place. So there's a bunch of bias, to go back. And that can be hard to try and find conclusive things. Like if I said, is this enough information to tell if this code is vulnerable? Probably not. But it could indicate if it had certain strings on that blog post that were also present in my own code, then it might flag it.
Right.
But if maybe I gave it a snippet that's just a list of these codes, or these strings that could be in that blog post. And then it says, oh, well, it's vulnerable because these strings are the same. But really, I could be designing a detection algorithm that's scanning for those strings as well. It's not vulnerable. So it could be misled is what I'm trying to say.
Yeah.
There's a lot of misnomers that unless you truly understand the context, it's really hard to be able to extrapolate and then apply it. So like in one of my roles when I was working prior to my PhD, was as a cyber threat huntress. It was one of the coolest jobs I've done. I kid you not, professional title.
Cyber threat huntress.
Yeah. So our job was to take recent reports of security attacks that are things that might be going on and then see how that might look on our own systems. So if we heard a report that some state actors are targeting financial companies in the US to, I don't know, exploit some kind of service, then we would go through logs and figure out and hypothesize, what would this look like for us?
You try to do it.
And you try and manually search for, so we call ourselves the proactive defense. Very cool role. Definitely an inspiration to do more data science.
That's thinking of blue team, red team, or blue agent, red agent. There's also black hat and white hat, right? So,
yeah, we talked about this last time as well.
This is so in this case you're the white hat.
Technically we were purple in that case.
Oh,
because it's you know, primary colors. So blue team is defense, red team is offense, so attacking. Typically red teams, as we talk about them, are employed in the company, so they're doing it with like benevolent intentions. Right? They're just trying to help harden defenses. So one might call them like white hats of sorts. Black hats are hackers that are typically out to get an exploit, right? So they're not necessarily good.
They're the real people out in the world.
The bad guys.
Yeah.
Okay, but whereas
there's also
blue team, red team is like within an organization, but you're sort of like the red team would be trying to simulate what the black hat people might be doing.
Yeah, so they say things like, assume I have credentials of a software developer. What can I hit inside the company that I shouldn't be touching? And they're extremely skilled personnel because they're trained not only to attack, but also to attack without breaking necessarily. So they just want to show evidence enough that they have gotten there without actually ruining, you know, company activity day to day, which is, it's a very fine line to try and draw. So I find them as very impressive. But then, as I was saying, so purple team, we call ourselves purple because blue, usually you're sitting there waiting for alerts. You're just defending, you're responding to what's happening. But as a purple team, we were proactively trying to figure out how people were attacking or could be attacking and then defending that way. So it's a bit of both, which is why purple.
It's a bit of both, yeah. Cool. So what else have you guys been working on besides the cage challenge? It sounds like you've both got your fingers in a lot of pies. There's a lot going on here.
I mean, you just came back from Eugenics.
Yeah, I went to a conference in the US. So I do one of the areas of research that I do is trying to find vulnerabilities in web applications. Right. Trying to use reinforcement learning for that. I went to a conference.
One of the best security conferences in academia.
What's it called?
Eugenics.
Eugenics.
Or Usenix, depending on who you're talking to.
Yeah, I've been told that I pronounce it wrong.
I've also been told I pronounce it wrong, though. So,
all right.
We are at a loss.
For everyone who's listening, it's Eugenics. So I went over there because I did some work with some people at Imperial based on trying to find SQL database vulnerabilities in web applications. We found, I think, we tested like 11 or 14 different web applications. We found vulnerabilities in 5 or 6 of them, including some, like if you're familiar with WordPress, we tested it on a bunch of plugins for that. And we found, I think, 33 vulnerabilities. We got some like confirmed numbers for them. And then, we wrote the paper up and it got accepted there. So I was, over there this time last month, I think.
What sort of thing counts as a vulnerability?
That's a great question.
That's a great question. This is what I spend some of my time working on, especially when it comes to like access control. But for the context of SQL injection and web vulnerabilities, it's like, can I get it to do something which it's not supposed to? So if I have a web page and it's like, okay, I'm going to search Amazon for a really good board game, and I want it to return I don't know. I would name one, but I don't know if I'm allowed to.
TM.
Yeah.
I'm sure it's fine.
Exploding kittens.
Wingspan.
Monopoly.
I don't know about that.
I don't know if that could be right. Sorry.
But if I wanted to do that, yeah,
we don't like Monopoly clearly in this group.
there are shakes of the head going round. Yeah,
board game connoisseur over in the corner.
I'm just trying not to say anything and get back on topic.
We can get sidetracked.
We have a whole separate discussion about board games. So we won't name the board games, but if you were searching something,
if I were doing that,
yeah.
Then the web form would go and it would query the database and it would get me a list of all the really good board games. Right. It might bring back Monopoly, who knows?
Yeah.
And then what I might then try to do as someone who's slightly nefarious is try to get it to do something which it's not supposed to do. So I might try to get it to return like usernames or passwords so I can then do something slightly more malicious later down the line. So that's like what a vulnerability would be in this case.
Okay, yeah. And yeah, presumably most companies and websites, you'd have thought by now, like at this mature stage of the internet would have all of those things locked down.
You would hope so. So we did like as part of the writing of the paper, we found out that there was like 63% of web injection vulnerabilities were SQL injections, these database vulnerabilities, and that accounted for something crazy like 6 million or 6 billion in injection on web attacks in 2020.
Actually, so I have a question which I think I wonder if you know the answer to this. So of the kind of like vulnerabilities that tend to exist, or like the ones you found, are they like known vulnerabilities, as in like there are documented ways to like that they could do something about it and just haven't, or are they like genuinely you're always coming across new things?
So it's a little bit of both. So that there are known ways of protecting against this, and it's usually like, okay, well, don't allow users to input things which they shouldn't be able to input, or use the set way of defending against this, which for SQL injection is something called parameterized queries, and that means that everything is perfectly safe. But the implementation of this is only really as good as the person whose security knowledge it's based on. So you could have a whitelist of or a blacklist of things. It's like, don't allow these things. But if I find another way of inputting that thing, which then runs correctly, I've then bypassed what your defensive measures are, and I've been able to do something malicious. Or you've just implemented it completely incorrectly, and you've left it completely vulnerable. So it's kind of a combination of both. So you can imagine it as a kind of like a normal distribution, where most things and vulnerabilities might be captured in this like large kind of like set in the initial distribution, and then you've got this long tail where there's all this new stuff which we don't know about yet.
Well, that leads me on to an important question, which is, when it comes to thinking about how your reinforcement learning agents or AI in general might be defending against these kinds of attacks. What do you think? Are you tending to think about those tail cases or the not so much?
I feel like the tail cases are the fun cases. But we generally go for where the big bubble is.
Yeah, the common stuff.
Yeah. So the bit of work or the most of the work that I've done is on trying to find these like more edge case things in a faster way. Because it's one of the interesting things of reinforcement learning is it's really good at searching over these really large, vast spaces to find optimal solutions.
Is that more because? So we're thinking then because the solutions to like the common, I guess, in my language, hacking attempts is sort of mostly known.
Yeah.
So you have those solutions, but then so you're thinking about how to defend against the edge cases.
Exactly.
So a bit of a timeline for you. When a new exploit or vulnerability is identified and it's published, within a few hours, you'll see a spike in activity. Within a few days, you'll see it slowly progress into malware. And within a week, it'll be continuously, routinely scanned for and hit on as many things as possible.
Right.
And that's just kind of like a general timeline that is well known. Insert citations here.
So someone discovers a vulnerability that could be present in lots of different computers or websites or whatever.
You're looking at a 1 week timeline to see.
Right.
when it's going to really
and
be a
malware
problem.
just as well is like someone's sort of like taken like written some code that's going to do that exploit and like packaged it in a way that like then lots of other people could easily just download and like run without necessarily being a coder themselves. Although I remember you guys using the phrase before, script kiddie.
Yeah, I was just going to say, I'm impressed you remember.
I'm very impressed.
Yeah.
Yeah, so that's the different types of attackers that we typically go for. So what we were saying were the fun cases were these edge cases. And typically that's like a human has been given a very new tool, which is a new vulnerability to exploit, or a new way in which this vulnerability could be exploited. And then they are targeting particular companies, resources, etc. And they are really hard to catch because they're able to respond in ways that you won't be able to predict as easily, right? Because they're human, hopefully, right? Now, when they start using machine learning, we'll never know. But when it comes to script kiddies or this kind of like malware that we'll see, there's some ways of catching it and stopping it from at least hitting your resources because they're just running something over and over and over again. They might have a couple random things that they put up, a random number generator to, like wait some amount of time before running the next line, or reach out every 23 minutes, 42 minutes, like random numbers. But there's some kind of regularity between them so we can start to catch them more easily. That's the bubble part that we're talking about.
I see.
And it's not necessarily bad to target that because it is always changing. People's tactics change with the development of technology. I mean, how often do we swap out computers and different devices that we use every single day, right? They're also trying to adapt. So there is some changing, but it's slower pace.
Yeah.
So it's something that we can kind of say, look, we did it. Check. And then we can try targeting the fun cases, which is the ad cases, if we have that kind of data.
So I'm just trying to think, like, is there a future scenario in the world where instead of the sort of scenario you just laid out, where like within a week, lots of people are hit, or lots of companies or computers or websites are hit by a new piece of malware that's just been
never seen before,
that there's the first line of defense, which at least blocks X% of people who would get hit by that now, which is like you've always got this AI network defender that's different from current sort of antivirus stuff, in that the current stuff is only going to be defending against known attacks, whereas this is going to be like actively defending against something which is never seen before, potentially.
Well, so that's I guess to your question before, when you're talking about how do we see machine learning being applied in our field, I think that's why we were so hesitant to say anything, because a lot of the ways in which machine learning is trained right now, there's a lot of static parts to it. So I have a data set that I've taken from this time range, and now I've trained this model, and now I'm going to throw it into a production environment. But in our use case, we always have to think about what would happen in the continually changing environment. So there's some dynamic nature to it. And it's not just the stochastic nature in the sense of things could randomly occur and randomly not occur, but it's actually, it showed up in 2010, and now we actually still use some of the same base software or something, but we've now added all sorts of things to it. But somehow we've accidentally reopened a trapdoor that was previously blocked, right? So some things can always go back. So there's a few machine learning fields that I've been keeping my eye on because I do see those as being critical for our field. Reinforcement learning being one of them because of the way it's able to dynamically, as you said, right, generalize across multiple scenarios and explore really nicely. But there's also active learning or online learning or lifelong learning. It goes by several names, but it's essentially the same thing, where over time, the environment will change. That's the assumption. But the main crux of the problem that they're trying to solve is something called catastrophic forgetting. If I was able to defend against something in the beginning, can I still defend against it after some amount of time? So if I re-see the problem, right? That's what you want to be able to figure out.
Yeah. So you, in this scenario, it's like, the reality of computers are being updated all the time. There's new hardware, new software.
Yeah.
can the same approaches, or can the same agent even continue to defend?
Yeah. So not only can I identify it, not only can I remember it over time, but also can I explain why I think I'm good at identifying it.
Ah, right. Okay.
And that is actually one of the hardest things in cybersecurity. I mean, how many times have we brought up analogies in this conversation already?
Yeah. That's the hardest thing in AI, really, isn't it? Because
trying to explain any of like these deep learning black box models.
Yeah.
I would argue cybersecurity is harder. So in some cases, like healthcare, we have a human nature, like intuitive understanding of how our body responds and how symptoms relate. So if I have blood pressure, a heart rate monitor, all these other measurements, I can kind of understand where a cold is being diagnosed or pneumonia or something like that. And I don't want to say that, to say these aren't these are simple signals, but I'm saying there's a layer of complexity that in cybersecurity is even harder. I mean, the layperson understanding of what does it mean to be secure, I think has improved tremendously over the last couple of years, just by the number of cyber attacks we as individual people have had to experience, right? I mean, people's data gets stolen all the time.
Right.
And we see spam emails and et cetera. They're getting a lot smarter than like just Nigerian prince or whatever the original one. I probably shouldn't just bring up one example, but so for us, right, we were talking about the logs we saw. So for the cage challenge, right? So we saw IP addresses, the names of programs running, but what does that actually mean when I say an attacker has come in? Like, you hear my language is describing it as if it's an intruder. A very physical person has like knocked down my door. But when you actually look at the logs, it's just numbers and strings that don't quite exactly say that someone is coming in through this door and doing this nefarious thing. We have to find some way of mapping that language. And that's why causal learning is quite interesting.
One person has run a query, as you were talking about earlier, SQL like they've queried a database, they've got some information from that, and it's like, how is that an attack? But it is an attack in that they've got something that they're not supposed to have.
And then when you try to chain that with like a bunch of other things, and there's like stuff in the middle, it's like, how do I know that what I've got is like, oh, this is clearly an attack that's going on, what it's based off of? It can be difficult to figure that out.
Very complicated, but reinforcement learning is going to do it.
Yeah, it's going to do it.
It's one stone in the wall.
Yeah.
So going back to the data quality idea, is there a way that you think the field of like AI for cybersecurity can like increase the data quality for what they're using for training?
Yeah. I mean, so that's actually, so my PhD is on the data quality question, right?
Yeah.
And so one of the ways in which I'm trying to help solve it is by going through not only how do we collect new data, so I'm looking into honeypots and how do we use them, but also how do we deploy them so that we can get the data that we need to remove
define
bias.
honey.
Yeah, I have a question. What's that?
Sorry. Honeypot. Kind of like a spy movie where there's like some very attractive person at a bar and then secretly trying to seduce the spy and then capture them and, exploit them or something. Anyways, a honeypot is an intentionally vulnerable machine that we leave exposed for attackers to come in and exploit so we can observe what they're doing. That's how we gather our data, right? So if I want to say, what is the current best ways to defend, I can start to say, well, some percentage of the attacks that we see on this cloud provider are from botnet nodes or from people trying to SSH in or from exploits of WordPress. We have these kinds of metrics. We have to figure out how do we collect that data. So by deploying honeypots, we try and do that, but there's a lot of considerations because not only do we want them to come in, but we want them to not get anything for free and we want to watch them without them knowing. So it's kind of like going into a safari is how I like to relate it.
Yeah, I was about to ask, do you invite people to this or?
No. So, the honeypots I've deployed have been exploited within 2 minutes. So that's just leaving
But like, how do people even know that it's there?
There is continuous scanning on the internet.
Right, okay.
All the time. So I spun up a cloud server and I those come in a set IP range.
Mm-hmm.
And there are people out there that are continuously scanning that entire range, looking, knocking on every door.
Right.
All you have to do is just leave a crack open and they will push it.
And hopefully normally when people are doing that, they would go by, IT security best practices. And so like those really easy things hopefully don't tend to happen.
Yeah, but if you've developed a web application or anything that you've just been prototyping, how many times have you left user and password as the user and password?
Right.
Those are the kinds of misconfigurations that are continuously scanned for.
I see.
Yeah.
I see. Well,
so one of the things that I was looking into was a lot of these studies that we do with these honeypots are observational, right? So we leave a whole bunch being some vague notion, right? For as long as possible and count how many people have knocked and collect as much data as possible and then train some models on it.
Yeah, okay.
But is there some way of interacting with the attackers so that we can actually gain very targeted information? And we could probably do that quicker. Because you need to know
what happens when you're trying to defend against them. But if you're trying to defend against them, they might not do the things that you
did or what they did before. Or, there's all sorts of questions that can come up. So that's one of the things that I was looking into. So that's one part of bias. So that's confounding bias. So what I actually took inspiration from was with a conversation with a master's student who is studying from COVID days, right? These different clinical trial studies. So in clinical trials, you have this treatment that you're trying to see how well it does at curing a person of a disease of some kind, right? And during COVID, there was such an emergence, right? A need for these to happen faster.
Yeah.
And that clicked, right? For me, when I'm thinking about how much intrusion data do I want to collect, I want to collect as much data very quickly. So I was like, why can't we take these methods and apply them into cybersecurity? And there's a few limitations that are quite interesting, but actually in a really good way, such as a targeted question or hypothesis that has to be answered, right? So a treatment has a certain effect. Can we ask the same kind of questions in intrusion data collection?
Can you do a controlled trial for cybersecurity is what you're asking? Right.
And I ran one.
Right. How'd it go?
It told me something that it wasn't like obviously new. So it was essentially, if I accept anyone who knocks on the door with any password versus only just the word password, is there a obvious difference? And do I see traffic? And there is an obvious difference between the two, right? One is the subset of the other. So that was the part that was a little bit obvious. But what was really interesting is we could answer that very quickly. Within 4 hours, about 40% of my honeypots were exploited across the different regions in the US that I was deploying them on this certain cloud provider. So that was my first clinical trial study. And now I'm looking at running another one that's a little bit more intense, more along the lines of what Myles is working on, where we have a web application with certain vulnerabilities. And if I remove some of those vulnerabilities, how does that impact the number of attacks that I see? And this is just trying to build up this causal knowledge of how these things relate and what causes the attackers to do certain activities, assuming that they're, kind of the same script kiddies running over and over and over again.
Right.
Which is a strong assumption, but we have to start somewhere. So, yeah, that's kind of where my work's been taking me.
And that's so the ultimate outcome of that is really like the data which could then be used.
Yes. So the relation to data quality. If I assume or find that my data is biased in a certain way, one way of undoing some parts of bias or limiting the impact of this bias is by collecting data that would unbias the data set. So if I say this field should have zeros and ones, but I'm saying 90% are ones and only 10% are zeros, then I would want to collect more zeros, right? So that way I can have a better understanding of the other variables in the data set. So I don't just say that one is correlated with the other without actually understanding. And the way you do that is by intervening. So I say, I will only collect data where this is 0. And that's kind of what these clinical trials are doing. So I say I'm going to intervene. I'm going to treat some of these instances, some of these honeypots with a certain vulnerability or not treat it. And I'm going to intervene and only collect data in that case.
Okay. So you end up with a richer data set of like different...
And an understanding, yeah.
Yeah.
An interventional understanding, yeah.
Well, this is this is all really fascinating stuff. We're running a bit low on time, but just before we let you go, Kate and Myles, do you have anywhere online that people can find out more about your research, or any final thoughts you want to share with the Turing podcast?
Thanks for having us. Mainly, it's been pretty good so far. I can be found online with, I think I have a website somewhere. If you search for like just Myles Foley, I'll pop up there somewhere. There's one picture that I use for all of my things. So if you find that, you'll find all of the things for me. Twitter, or X as it's now, I suppose, known, although I don't really use that anymore. All the things. Go read all the papers. They're really great.
Yeah, same for me. I just want to do one more plug though on behalf of Chris and Vass on our team, right, for this AI for cyber defense group that we've been really excited to be a part of, as well as just the defense and security program at the Turing Institute.
I'll sing their praises. This is I won't say who said this, but someone else at the Turing described your team as the rock stars of the Alan Turing Institute. So,
wow.
Nice. I mean, you're out there winning competitions. So, you know.
Well, you can join us, is what I was going to say. So they have positions open and a website coming up, or should be up already.
We should say this depends on when this goes out. So when
so at any time, just check the website.
Okay.
Yeah. So they have some positions that end next month and this weekend, but yeah.
But hopefully more in the future.
There's going to be more in the future, so just keep an eye on the website.
Keep an eye on the...
And they also
that'll be on the Turing website.
Mm-hmm, should be.
Turing.ac.uk.
They're also doing funding for project proposals, which is a new idea.
Okay.
So if you have a really cool autonomous cyber defense project and you need funding, you can submit proposals to Chris and Vass. Maybe even get to talk to them, the real rock stars.
On that note, thanks for coming.
Thanks for listening to this week's episode. The show is hosted by me, B. Costa Gomez, Ed Calstri, Joe Dungate, Christina Last, and Anika York, and the episodes are produced by Luca Lane. Music for this podcast is produced by Jam and Sun. You can listen and follow via the link in the description or by searching Jam and Sun on Instagram.